Hello everyone, I'm Kamal Noori and here is Remote Sense Geosciences channel. Today we want to talk about Terra powerful satellite. Let's start. Terra powerful satellite. The satellite was launched from Vandenberg Air Force Base on December 18, 1999 by NASA on board an Atlas IIAS vehicle and began collecting data on February 24, 24,000. It was placed into a near-polar sun-synchronous orbit at an altitude of 7,005 kilometers with a 10:13 a.m. descending node. Terra's mission. Terra explores the connecting between Earth's atmosphere, land, snow and ice, ocean and energy balance to understand Earth's climate and climate change and to map the impact of human activity and natural disaster on communities, communi- communities and ecosystem. Terra instrument. Terra collects data about the Earth's biogeochemical and energy system using 5 sensors. Each sensor has unique features that enable scientists to meet a wide range of science objectives. The 5 Terra onboard sensors are ASTER, or Advanced Spaceborne Thermal Emission and Reflection Radiometer; CERES, Clouds and Earth Radiant Energy System; MISR, Multi-Angle Imaging Spectroradiometers; MODIS or MODIS, Moderate Resolution Imaging Spectroradiometer; MOPITT, Measurement of Pollution in the Troposphere. Example of each instrument's capability. ASTER for land composition, CERES for reflected energy, MISR for aerosol, MODIS for vegetation, snow and ice, MOPITT carbon monoxide. Designed and built in the 1980s and 90s, NASA and Lockheed Martin engineers set out to build a satellite that could take simultaneous measurements of Earth's atmosphere, land, and water. This slide is showing ASTER sensor specification. On the left, VNIR, SWIR, and TIR, three parts of ASTER sensor. Next, a spectral band from band number 1 to band number 14. Next, spectral range in micrometers. For example, for green band 0.52 to 0.6, and for 14 10.95 to 11 to 65. Next, scanner type. Next, detector. Next, spatial resolution or grand resolution. For example, 15 for VNIR or 30 for SWIR and 90 for TIR or thermal infrared. And final column, signal quantization. For example, 8 bit. for VNIR, or 8-bit for SWIR, or 20-bit for TIR, or thermal infrared. But this table, the central wavelengths of aster bands. For example, B1 central wavelengths equal 0.56, or B2 central wavelengths 0.66. But this slide update on Terra's new orbit. This is important. Since 2020, Terra has been drifting to an earlier equator crossing time, and in October 2022 was lowered by approximately 5 kilometers in altitude. This change in orbit did not reduce the data quality of Terra products and only created minor changes in to orbital repeat time and SOAS for some instruments. Reference NASA site. This slide estimated future changes to Terra's equator crossing time and altitude. Horizontal axis is showing month per year, and vertical axis is showing MLT, equator crossing time. MLT means mean local time. This slide is showing index map of aster images by row and pass. And final slide, this perspective image of complex volcanic landscape in the Andean mountain range was assembled from data acquired by aster on April 9, 20 and 3. Aster products image using infrared, red, and green wavelengths of light. Vegetated areas range in color from red to pink. Snow is white, water is black, and bare rock is earth tone. Many thanks for your attention.